My name is Michel Destrade. Oh, I didn't write my name anywhere. Anyway, I'm the chair of applied mathematics here at the University of Galway, and I'm within the discipline of applied mathematics. If you want, there's a few of us working in applied mathematics, but we're all part of the School of Mathematical and Statistical Sciences, and we're offering all sorts of degrees. But today I will present what kind of degree or pathway you can follow if you're really into applied mathematics. Tomorrow I will be talking about the applied mathematics course, the first year course, and you might be interested in that too if you want to know more. Today it's all about degrees. My first slide is about jobs. Yeah, job prospects. I don't know any parent listening now. Often they often ask that question, which is fair enough. But students also are interested in that type of outcome. Of course, you want to choose your degree well. You want to make sure that you're going to enjoy the course. You want to enjoy the knowledge and the experience, and you want to become, you know, a more clever, more rounded, more educated person. But also you want to make sure that you want to get a job easily at the end of the degree. And if you look up CareerCast, it's a website that every year comes up with the top 200 jobs. And you look through the years, you will see that mathematics is really always in the top 10. Here I've just put 2018, 2021, and you can see that 2018 was actually that was there, and 2021 is data scientist. These are jobs that are heavily rely on mathematics, right? And if you do a pathway here, there's in fact now a new degree in data science that we run. You will get easily a job as a data scientist, as a mathematician, as a statistician. I will recommend you do some statistics, and that's often included in all those degrees. It's in high demand, and also the ranking is not only about the outlook. It's for you whether you find a job easily. It's also based on you know, the environment. Is it an enjoyable job? Is it a stressful job? Does it pay well? And those type of mathematical jobs always pop up in the top 10, even top 5. Okay, so today I'll be talking about what is applied maths here, not in general, but here the way it's presented in the university. And so these are the topics I'll be running through, talking, including applied maths. I'll show you some testimonials, and if you're interested in talking to a former graduate or even to current students, you could just contact me, and I'll put you in touch with them. Just email them and ask them what's it like to study maths and applied maths at Galway. Okay, so let's get started. What's applied maths at Galway? You will see that mostly in the first year anyway, it's all about mechanics. And if you've done applied maths in the Lead Cert or physics, you've done a lot of mechanics already. But this is why I'm emphasizing here with the frame. You don't need to have done applied mathematics or physics to take this course, right? We just assume nothing about your level. We just take it from scratch and bring you all the way to a good level at the end of the year. So it's a course that students enjoy a lot, especially the first semester. But I'll be talking about that course tomorrow in another session. And then what else can I say? It's basically all about problem solving, right? We talk about Newton's law, and then we apply that to, I don't know, collisions, trajectories, motion, all the way at the end of the course, talking about planetary motion. And we derive Kepler's laws, you know, the laws of planetary motion. We derive them mathematically, which is pretty amazing. I'm always enthusiastic about that part of the course. Okay, that's first year. And don't hesitate to interrupt and ask questions on the way in the chat box. And then in second year, we also do mechanics, and then we do what's called mathematical methods, because of course you need to improve on your skills to be able to solve harder and harder problems. So you need to do, you know how to differentiate, where we're going to use that to study what's called differential equations and solve them, because those pop up all the time in applied mathematics problems and in physics and engineering. So then in third and fourth year, we have more specialized courses that are also really excited. There's a course on fluid mechanics, and here there's nice animation of a football going through the air, but the air has been, there's some jets that are colored, so you can see how the flow is at first is laminar and then becomes turbulent in the wake of the ball. And then quantum mechanics, that's an amazing theory that can actually is very successful at modeling the behavior of atomic and subatomic particle. That is in third year, yeah, or maybe in fourth year. Pretty nice. What else do we have? Nonlinear systems. That's very applied, and students enjoy that. It's basically solving differential equations and look at the properties of the solutions and so on, all the way to describing chaotic motion. And then nonlinear assisted, that's the course I teach, is to describe the motion and the deformations of soft solids, right? So just think of rubber or gel, silicone, or soft tissues, like the biological tissues in your body. How do they deform when they're subject to forces? So pretty advanced topics, and yet every student managed to reach a good knowledge of each of those topics that then make them employable, because they learn a lot of skills, and also make them attractive to former studies, further degrees, if they're so inclined to go on and do a master's or PhD. Okay. Oh, I forgot there's also a course on cosmology and general relativity to describe, I guess, the cosmos and the motions in the cosmos and so on and so forth. So that's pretty mind-blowing. I haven't taught that course, so I don't know. I've only studied special relativity. I guess that's pretty advanced. And then there's a beautiful module on electromagnetism and the theory of electricity, magnetism, light, and the interaction with solids. Very, very beautiful topics, in my opinion. Okay, now I'll talk about the degrees you can take that involve applied maths. You could choose to do what's called the undenominated degree. That's when you do a science degree, and basically you pick up the topics you like the best. You start with 4 topics in year 1, and then you just drop them as the year go by, so that in the end you have only 1 topic, or you can actually have 2 topics if you want it. So here's an example. You could start by saying, okay, I like maths, applied maths, computer science, and physics, or maybe biology, say, and then at the end of first year you say, you know what, I don't know, computer science not for me, I'm going to drop that. And at the end of second year you say, physics, that was nice, but now it's too experimental, I prefer the math, I'm going to stick with maths. So you can then in year 3 and 4 specialize into a maths degree, or an applied maths degree, or in fact into a maths and applied maths degree. And like I said already earlier, you don't need to have done applied maths or computing to take, or physics, in fact, to take those topics. Okay, and that's a large class. 300 students take those take that path. And there's some courses where there's 200 students in the same class in first year, which is pretty impressive. Oh, I had a pop-up, it didn't come. Okay, so I show you some examples here. Fionnuala, she did really well in that applied maths degree, and so well that she got accepted at Harvard to do a PhD there, and now she's back in Galway, working at Medtronic as a research engineer. Niall, he did his degree in science here in applied maths, then you do master's in Oxford, and then you do a PhD in Cambridge. Did he? Yes. And now he's working in Princeton. I don't know. I must look him up. I think he's a researcher. Yeah, that's it. He did a postdoctoral research at Princeton. Pretty cool. Okay. So like I was saying, you could do a science degree where you pick options, mathematical options, or you could do a denominated degree. And we have those three. Those three I'm showing here have a lot of applied maths, but we have other degrees. We have mathematics and education, but that's an arts degree, so I won't be talking about that today. Mathematical science, that's, like I said, a cohort, about 30, 40 students every year. And then physics, that's about the same, 40, 50 maybe. Financial maths, that's 50 students, maybe 60 now who are doing this. So here I show you where they do applied maths. If you were to do the mathematical science degree in first year, you will do applied maths. You will do the 4-hour course of maths. And then in the subsequent years, then you will decide what type of mathematics you like. Maybe you won't like applied maths, then you'll say, I'm just going to do pure maths from now on, or I'm going to do a little bit of applied maths, not too much. Or maybe I like statistics, I like data science, I like computing, I'm going to focus on those topics. So it's pretty custom made, but with a mathematical slant, of course. And there'll be a talk about this on campus Friday at 1 p.m. And I forgot to say there'll be a talk about the general science degree as well. So it's Kira. She did that degree a while back, and she said that even before she did the final exams, even before she graduated, she was already approached by first derivatives. I don't think she's in first derivative now. I think she's in Accenture. Anyway, she went on to do financial maths. She got a job before she even started. Alan, he went abroad, study abroad. So I don't know if you're going to have a talk about that, but it's possible to go for a semester abroad. You go to Hong Kong, you can go to the US. Yeah, there are a few universities with which we have agreements. Okay, and now he's working as a consultant in London. Pretty nice. Okay, the other degree, and there'll be a talk about this on Friday, that's very well attended, is the one financial maths and economics. So here you do mathematical methods. That's what I wrote here. That's the applied maths. And then after that, I think it's not really applied maths, more financial maths, which in a way, I guess, is applied mathematics. And then if you were to do a degree in physics, then you will do a lot of applied maths. You will do applied maths in first year, you will do applied maths and maths method in second year. In third year, you will do maths method. And then if you're doing the theoretical physics trend, basically in third and fourth year, you will do half applied maths, half physics. Somebody is asking, if you do an exchange to a foreign country, do you have to arrange accommodation for yourself? That's a good question. I guess it depends on the country, but there's a lot of support here. Yeah, I think you will be helped the whole way. I know a student who went to Berkeley, for instance, last year. He chose to go in the student residence. Anyway, you'll be put in touch with the university there, and they will help you. And I presume there's a lot of knowledge around students who do that every year. I'm sorry I don't have more information, but like I said, there's a lot of support for that. Okay, 10 minutes left, so I gotta. Oh, okay, I'm gonna be okay. I'm finished about those degrees. Yeah, if you have any question about the degrees, don't hesitate. Here I'm just listing the topics that we work on. Yes, of course I should have told you I'm a professor, so I teach applied maths. But also I'm a scientist. I do applied maths for a living. I work on problems, and so do we all, right? It's not like we only work when we're teaching and then go home or go on holidays in the summer. We do science. We try to solve problems. Maybe we follow them up with experiments. We're real scientists, and then we write them up as scientific articles, put them in journals, present them at conferences. Some of us, have patents and so on and so forth. So yeah, some of the topics we work on. Personally, I'm interested in nonlinear elasticity. I was telling you about this earlier, and so that's at the interface between applied maths, physics, and engineering, mechanical engineering, and biomedical engineering, and medicine, in fact, because I'm interested in the application of those programs to medicine. Just to show you the type of work I do in the end, I try to model the mechanics of the brain. So that's pretty difficult, right? You have to test the brain in the lab. Once you have the material properties, you put them into computer software code, and then you can simulate what happens in the brain when you punch it, right? That's how the students feel about me sometimes. No, I'm joking. Somebody is asking, is applied maths the best math discipline to pair with a physics-based degree? Yes, I think so. I think so. If you were to do a physics degree, I can't remember the code now. There's 4 strands in the physics degrees, right? There's applied physics, astronomy, medical physics, I think, and then there's one called theoretical physics. If you were to do the physics degree with theoretical physics, then you will be doing half physics, half applied maths. If you were to do the science degree, it would be, in my opinion, it would, and you're into physics, it would be a good choice to take applied maths as well, because there's so much overlap, right? It's just the same. The only difference is that in physics you will do some experiments, maybe you'll be in the lab, and if you like that, you should definitely do it. Okay, so there's my name. Actually, I wrote it here. I forgot to say I'm French. I forgot to ask you, could you understand me? I guess you seem okay with that. Okay, another question in GY301. So that's the science degree. Year 1 is applied maths all exams or any continuous assessment. So every module has a continuous assessment part. Every module. I won't say every module in Galway, but at least every module in applied maths does. You typically it's 30%, 70% for the exam, 30% for the continuous assessment, 70% for the exam at the end of the semester. Then if you fail, so then you compile your final mark. If you fail, if you have less than 40%, then you have to repeat the exam in August. But yeah, it's half and half. Now this year is, oh yeah, you're entering, I don't know actually if you're entering into first year, you might be in a TY or you might be in the leading third year. This year is a bit special because the starting date is so late that you wouldn't be able to take the Christmas exams, the first semester exams, because they happen in December and you will still be in class. So there's no exams in semester 1. There's no written exam in a room on a small table and so on. So continuous assessment is more important in semester 1 module. I guess semester 1 module is continuous assessment only. So that might include in-class tests, so 1 hour in-class test, but not a big exam at the end of the semester. And then semester 2 and years after that, it would be 30% during the semester, 70% at the end. Typically, some modules are 20/80 or maybe 40/60, 33/70, 66, but typically that's what it is. And then in the years to come, if you're entering the university next year, I can't tell you because I don't know when the year is going to start for first years. And so you can try to send me an email. I'm easygoing. And also the other thing I can do is put you in touch with current students, right? I'm teaching first year and third year and fourth year students. They're just like you, right? They're just a couple of years older than you. And if I say anybody who is willing to answer questions to an incoming student or somebody, yeah, I guess if it's orientation, you all incoming, right? Anybody's not interested in answering an incoming student, I'm sure some of them will say yes, right? And don't be shy about it. They're just regular people. I'm sure when you're a student, you'll be happy to help incoming students and tell them what it's like. And I think talking to students is the best way to know what it's like, right? Because I'm selling you the degree. I think it's fantastic. I love applied maths, and I never tire of it. But I'm biased, right? Of course, it's better to find out from the other side. So don't hesitate to write to me. And if you want to be put in touch with current students, don't hesitate to ask me. I'll ask them, and I'll give you their email, and you can ask them all the questions you want. Okay, so 1 minute left, and then I'll have to stop the session. Final question. Somebody said, thank you. You're welcome. I hope to see you soon. I'll be teaching applied maths in semester 2, so be ready. And take care. Bye-bye.